Now, then we'll switch to Dijkstra. And I'm gonna make you straight away scared. This is Dijkstra algorithm from Wikipedia. Well, this is nasty. We're not gonna read that, right? We're gonna have a look at the Wikipedia simulation, or the GIF, the animation actually. Well, this is still kind of difficult. I saved you some time and I made the animation a little bit slower. So what is the idea of a Dijkstra algorithm? A Dijkstra algorithm is a way to find the shortest path between two nodes. And the idea is that there's a lot of nodes in between, and the distance between those nodes can vary. That's the idea of Dijkstra algorithm. We will see later on that we can also use it for even a much simpler situation. So do we know the shortest path already? Well, when we look a little bit, I can probably find the shortest path, but let's see how Dijkstra algorithm does it. It's a Dutch algorithm, and it was invented on a place in front of a bar, and he did it in like 5 minutes. So the idea behind it is pretty simple, and he's still world renowned for that algorithm, and a lot of other algorithms are based on this. So what Dijkstra algorithm does, it starts with a node, with A, the red node, and then it calculates the distance till the next node. Well, in this case it doesn't really have to calculate because it's just a straightforward link, right? So this is 7. Agree? This is 9 and this is 14. Well, this is pretty stupid because it doesn't have to calculate anything, right? So what it does next, it takes another node, one of those he already did. Let's say he takes 7, and he's gonna do the same trick. So what kind of number would you expect here?
22?
Yeah, I think so, eh? You could say 15, but I think probably it's gonna be 22. That makes sense. So let's see what he gives. Where's my cursor? Oh, there. Okay. Yeah, 22. Yeah. So it's just 7 plus 15, right? So pretty straightforward. Now this distance, this number, what should he put there?
Nothing?
Yeah, true. You could say he should put 17, but 17 is bigger than 9, so that doesn't, well, that's no use, right? So he doesn't change this one. He doesn't change the 9. Okay. So he doesn't change it, just leaves it. Now he did those two. Now he can do another node. So let's say he takes the 9. Then we do the right one. So this 10 and 11. So what do you think, Farah? What's gonna happen here? This is 9 and 11. Yeah. What is gonna happen here?
Yeah, it's gonna change to 20, I believe.
I think so too. Yeah, 20. Okay. And this one? Also, right? It's gonna change to 11. Okay. 11. Okay. And now we take this node we finished. Now we take another node. We can take this one. Well, I sped it up a little bit, but 11 plus 9 is 20, right? So this is 20. This node, let's see, 20 and 6 is 26. No, this is not going to change. Okay. What is the shortest route now?
From A to 9 to 11 to 20.
Yeah. How can you see? It's actually really difficult from A to see what's the shortest route is, but from B back it's actually really simple. How do we do that?
Do you subtract?
Yeah, you're just gonna see, hey, how am I gonna go the quickest down, basically, right?
Yeah.
Because here I'm gonna go down quicker than this one, so from B I need to go this way. Here I can go this way, but it's 14. This one is actually easier, so I'm just gonna go this one. This is like a lower number, boom, and I'm gonna like this. So this is the shortest route. So this is basically a Dijkstra algorithm. But in your case, a lot of times you're gonna do it differently. Because what are in your case the nodes for most of you? Anybody?
What do you mean? Like, what are our nodes?
Yes.
Well, they're more in a, I guess, in a graph, not necessarily in a tree. Like,
Yeah.
is that what you mean?
Yeah. Well, yeah, I think so. More in a grid or a 2D.
Yeah, grid,
Yeah.
graph. Okay.
Yeah. So this is the same thing, but now for a grid. And all those nodes, what you see here, is actually the same thing as this, but now the distance between each node is 1. And then, well, you can do the same thing, right? Yes, Eric, or not? You look a little bit phased out, but are you phased out or are you still following?
No, I was kidding.
Oh, okay. So if you do, and again, this one is from Wikipedia, but we're just in like 10 minutes or 5 minutes, we're gonna do it ourselves because I made this one and it's available on Canvas, so you can check it yourself. So basically, this one does the same thing.
You made this one in particular.
They're close. It looks a little bit the same.
Does it take a lot of time?
No, not at all. This is just like it takes a long time to show it, to visually show it, but
Can you also start in the middle?
yes, doesn't matter. Doesn't matter.
And it's also going to the left bottom.
It
or
determines.
only to the right top.
It doesn't matter. The starting point, it just calculates the distance between each point, right? When you look at this
Yeah.
one, I could also see from here what's the shortest route, right?
Yeah.
And then you would see that it's this route. It doesn't matter. The starting point matters. The end point does. It does matter to know the shortest route between two points, but the end point you can pick whatever you want.
Yeah, okay, but for the start point not, or also.
No, for the start point you need to pick a start point.
Okay.
You do need to pick a start point. Hey, can all of you? Let's see. Yeah, we're gonna run the Dijkstra algorithm. So it's on Canvas. Somewhere. I don't know where. Probably just in the files. Let's run it. All of you. Oh, this is a little bit a giveaway, right? It's called Dijkstra algorithm, so that's no rocket science. Downloads. And the way I programmed it, it's not the most efficient. You can do it smarter, but okay. It works. Let's say it like that. Are you all opening it? Basically, the Dijkstra algorithm is this part. This is it. So it's not that difficult. Let's see. I tried to run Spider, but did it start in a different window? I don't know. Hello, Spider. Where are you? Ah. Is it clear how it's working? Is it clear for you?
I see some colors when I run it.
Yeah, that looks good.
What do I see?
You see parts where it's blocked, where it's not allowed. And you see the colors is probably the same thing which I indicated in the simulation I showed you. It's like, what is the value of the length of that point? Let's see. My computer is running really slow, but that's because all the things are open right now. I'm gonna stop recording for a moment, maybe that helps.